клиента больше всех хотел, когда он принял. Ну-ка напиши ему в личку. Сейчас прием.
We already started the stream. Okay, hello everyone. We will wait for 2 more minutes in case someone will want to join us. Hello, братец. Салам пополам. Okay, I see that people joining. 1 more minute and we will start. Our plan for today, we will have a small introduction, about 15 minutes on functional programming, and after that we will continue our discussion in free format. What the result of discussion is depends on you, but let's keep it as clean as possible.
Отвалился флаг.
Yep, but maybe he'll join later. Okay, I think it's time to start. My name is Andrew, in case someone don't know me. And I will give you a small introduction about functional programming and what I think about it. What?
I will be streaming.
I already streaming.
I don't see anything.
Can you open a link from Telegram chat?
On YouTube?
You can mute the stream and open presentation and change slides with me, or I can share my screen actually in the call, and you just mute the stream and read comments on the stream. 1 second. Functional programming. Bum. Oh, mute your mic, please. Mr. Drake, thank you. Oh, it's sorting concurrent viewers. It's a lot. I didn't expect so much people, but let's start. Anyone can see slides? Everything is good. Stream is okay. Can you type plus in the chat if you can see what is happening here? Cool. Okay, let's talk about the first concept that I think is very important for our today talk. Hello. Thank you for pluses. It's a value. What is a value? Actually, a very good talk about value of values is done by Rich Hickey, and you can find it here using this link, and it's really great and worth watching it. But I will mention two very important properties of the value. Value is immutable and it's semantically transparent. That means that value never changes and you can compare two values easily and you can see if it is the same value or different values. To work with values, we need some places to store those values. And it can be anything: memory, file system, network service, or address book. And in programming, we very often use a notion of variable. It's a reference to a place where the value is stored. That means that variable is almost always some address and the symbol which is associated with this variable. And it only points to some place where the actual value is stored. But as we remember, value is something immutable, and if you change the variable, you don't actually change the value. You change the place where the value is stored and update it with new value, but value still exists somewhere in universe. And let's introduce another entity called state. It will be a union of all places that we interact with. And let me demonstrate some example of value. For example, you chatting with me and I giving you my email. You opening your address book and writing down in alphabetical order somewhere and you're dropping and my email. After that, I realized that I have another email and it's much more prettier, and I type it in a chat, and you need to update the email in your address book. You scratching your paper and writing another email, and after that I understood that it was a mistake in my previous message, and I send you another one, and you again scratching your paper and writing new email. Actually, we have 3 values, and as we can see, they semantically transparent. You can compare them easily and can distinguish them. And how we will imagine a variable in terms of real-world example. If you write a sticker, and on a sticker you have a page in your address book, and you write it's Andrew's email, page 37. It will be kind of variable, and it doesn't mean what it doesn't matter what you wrote on this page. You still have all 3 values in your memory. It doesn't disappear from the chat, from your memory, and those values still immutable. But in your address book, you update the place where you store this value. But all 3 values still exist. It's very important. And in our programming life, we use different values, from simplest like constant string or immutable strings or numbers, to more complex like vectors or dictionaries, or even aggregated values like JSON or EDN or some other formats that represents values. And interesting property about aggregated values, that aggregated value is also a value. It's still immutable and it's still semantically transparent. That means that you can compare 2 different dictionaries which contains vectors or sets inside. What we do in our life of software engineer? Actually, we creating information systems, and these information systems very similar in most cases. They going to some place, getting some values from it, uses those values to produce another values, and saves or presents those values to user. And it helps users to make some decisions. And if we take a look at 2 items in the middle, we will see that those items actually operates on values, and it's most important part of our information system, because this part make us support us to make some decisions. Let's go to some history, and let's talk about imperative programming and how people used to do programming in current state of software development art. First, languages was very simple. It was just commands to processor, and it was a list of statements which says to processor what to do. And after that, people decided that it's too hard to use such list of commands because they become too big and hard to maintain or edit or implement some useful stuff. And they decided to simplify it and to increase the level of the language that we use to describe our programs. And they created first languages like Fortran, and much more later some languages like C. And the imperative program looks like a list of statements, but those statements a little more high level than assembler, but still pretty low level. And each statement tells to the interpreter or to the processor to do something with some places, to access a memory, to access a network, or something else. Later, people decided that it's still hard to write such programs, and they introduced more structure to the program, and structural program appeared. And now you can combine few different statements and say that it's a one statement. And you execute those three statements as a one statement. And our control flow constructions allows us to manipulate a few statements at once. Later, people decided that they need more flow constructions like for, while, and other loops, and other flow construction like switch, and so on. And after that, people decided that it's a lot of repetition in the code, and we can combine a lot of statements and call them procedure, and make some parameters for this procedure to change its behavior depending on these parameters. But procedure is still a list of statements which executed one by one, and each statement somehow, in most cases, modify places. And what we have based on this naive implementation, very natural actually implementation, that every statement doing something to the state. And in most cases, some statements depends on the state. And procedures is just a collection of statements. It's pretty much all that I want you to remember for our future discussion. Let's go to the functional programming, and let's go to history again. First paper, which is a basis for functional programming, appeared in 1930. It was done by the teacher of Alan Turing, and it was about lambda calculus. It's a very simple computational model which consists only of two things: lambdas, which is anonymous functions, and variables. And that's all that exists in those lambda calculus. Few rules like beta reduction and alpha equivalence, and that's all. But we will not go deeper in the details of this paper. We will go back to the history. In late 15th, first functional programming language appeared, and it was Lisp. And it's probably very important because I will be giving understanding of definition of functional programming based on notion of expression. We already know that some expression exists, and basically expressions returns the values. and they returns this value when you evaluate this expression. It seems pretty obvious, but it's very important. We have some values, we combine those values into expression, and after evaluating this expression, we're getting another value. Why it's important? It's important because we don't tell to our hardware what this hardware have to do. We just tell that we have expression and ask a program, our interpreter, to evaluate this expression and give us a value. Let's find another expression that a little more harder. And here we can see that the result of this expression depends on the order of operators. Because we don't know if it's mathematical operators or not, we will use another form of expression, which is a little more strict. Each expression will be covered with two brackets or parentheses, and first element of this expression will be function, and rest will be arguments. Arguments can be function or values or another expressions. For example, here we have function plus a value 2 and expression 2 multiply 3. Let's evaluate this expression. It's pretty simple. We will be doing evaluation by substitution. We have, it's not very important. The order of evaluation isn't very important because we always have immutable values and it always produces immutable values. We need to evaluate the orders that are nested, the expressions that are nested, but that's everything that we need to know about order. If we have few different expressions on the same level of the tree, abstract syntax tree, we can evaluate them in arbitrary order. But let's demonstrate how we will evaluate this example. We will take the most nested expression that is not determined right now because it doesn't have value yet, and substitute it with the value of the evaluation of this expression. And one more iteration, we getting this expression and evaluate it and getting the result. It's how most functional programs works. They just evaluate expressions. Is it clear? Is there some questions about what I talked to the moment? It seems that everyone is silent. It's two options. Everyone is sleeping or everyone is not sure what is going on.
Everything's clear.
Okay, good. Let's go to more advanced example. It's a factorial that we saw implemented in previous example, but in imperative language. Here is more functional implementation, and the root expression that we will be evaluating is factorial of 10. Actually, here we make an alias for this expression and call it factorial, and use this alias inside this expression. It's a very basic thing in functional and actually in functional programming, and everyone is already familiar with it. It's called recursion. We don't need to call to make a name for a function to make a recursion, but for sake of understanding, easier understanding, we will do it in a very familiar way for you. And what is going here? We have a root expression, and after that we need to evaluate the value of this root expression. We are going to this expression and try to evaluate this expression, but with a variable assigned a value 10. And here we evaluate this expression. But wait a minute, you said that, I said that we use only expressions. But here we can see if, and if is control flow construction. But actually, yes, in imperative language it's a control flow construction, but in functional languages it's another expression. And let me show you how we can implement this expression in a very simple way using our functional programming language. What is if? When we are writing if, let's call it my if, because we will be implementing my if, and it accepts true, we getting result, it was true. Oh, it doesn't work. The if is expression which have a first argument of true or false, and if the argument is true, it returns the first expression, otherwise it returns the second expression. The same works for false, but in opposite ways. It doesn't work. Oh, it works. It falls in condition. Okay, it's how if expression should work. Let's implement it. Define my if, and if accepts condition, first expression and second expression. But before defining if, let's define true and false. What is true and false? Actually, true is something that when it passed to if, returns the first argument of if, like first expression of if. Let's define true this way. Oops. My true. We have two expressions, 1 or 2, and we will be returning the first expression. Cool. And my false will be very similar, but it will be returning the second expression. And it's very strange implementation on first glance, but we will see how to use it. Now let's try to implement our if. And implementation of the if will be very simple. Thank you, Gleb. It will be basically a condition, which is true or false, and two expressions, which we will be passing to this condition. And if we do implementation this way, you can see that when we evaluate this expression, my if, my true, it was true, it will return true. And when we evaluate this expression, it will return, oh, it works, it false in condition. That means that it's not control flow construction, but it's actually an expression. In real languages, it's implemented in a little different way. But in our understanding of how it works, we can see that it's just expression. Okay, let's go back to our slides. If we will see how evaluation of those expression happens, we will see it evaluates this expression, and based on the result of this expression, it returns this expression. And after a few iterations, when n will be decreased to 1, it will return 1. And it will start combining back all the expansion of all those nested expressions. And it will be such kind of stairs going further and going backward. I didn't found a picture for this case, but sorry for that. You can find it in some books like Structure and Interpretation of Computer Programs by MIT. Pretty famous book, you probably heard of it. Okay, let's assume that we have one magic expression called do, and this expression takes to another expression and evaluates them and returns the result of the last expression. But such expression in functional language doesn't make any sense, because despite the fact what the result of this expression, we're always getting this expression. That is why in very pure functional languages, those expression won't be very popular, because it doesn't make any sense for this expression. Only if you want to omit the result of some expression during the computation. But in most cases, you see the difference between functional program and imperative program. In imperative program, we have a list of statements, and list of statements executed one by one and modifying some state. And each statement is important, and the result of the statement is written somewhere. In functional language, we evaluating expressions, and the result returned only one result of this expression will be returned. That means that other expressions will be ignored, and it doesn't make sense to evaluate few expressions in the row if we don't combine the result of those expressions. But in imperative program, you always evaluate each statement, because each statement affects the result of the program. And let's go to the function. For procedure, we said that procedure is just basically a list of statements which have some parameters to change behavior slightly of those statements. In function, we have a little hard time to defining what is it, because in mathematical sense, the function is something that establishes relationship between two sets. Here it's established using arrows, just from each element of left set to one element of right set. We can establish this relationship in different ways, using formulas, using some computation, or using those arrows. But in computer science sense, it will be something related to computations. And in functional languages, actually, the function is a list of expressions, but list of expression can be parameterized with variables. And that's all. It's just a list of different nested expressions that have some variables inside it. Okay, let's see the example of the function. We established in previous slide the relationship between figures and colors using arrows, but here we will establish it using our expressions. For example, we have expression which returns true or false in case if figure triangle or not, and the same for square, for rectangle, and polygon. And if it's triangle or square, another expression will return true, and in this case, if expression will return red. If it's not true, we will go and evaluate another nested expression, and we'll do same evaluation of nested expressions, and we will get the yellow at the end, because it's a rectangle passed to this root expression. You saw that we defined a function using arrows, but we actually can define a function using dictionaries. Dictionaries is pretty much the same idea like arrows in our picture. We're saying that we have a key and we have a value. That means that we have an arrow from this value to this value. And we actually can use this dictionary as a function. And we can construct an expression which takes this dictionary as a first argument and the name of the figure as the second argument, and return the value of the color of this figure. At the end, let's look on the difference of imperative and functional programming. In imperative programming, we know that there is a lot of statements which executed one by one, and some statements can change the order of execution. And if we look at it, and at first glance, it will be just list of statements that will be executed. In fact, in functional programming, we can see that you can get only value from root expression, and you need to nest a lot of expressions and get such a kind of strange tree that will be evaluated during execution of your program. And it's clear that you can get only one value from root expression, and it's much more strange structure than nice linear structure on the left. But actually it's not linear structure on the left, because some statements can control the flow. That means you can jump from statement 4 to statement 2. And actually from statement 3 you can jump to statement 6 in case in some place you have a value equal to true. And actually statement 5 can say that I want to update place 2. And statement 1 want to get some value from place 1. For example, from network. And statement 2 will write some value to database, to place 2. And if you draw all those arrows around those statements, we will get a mess. And actually, in imperative programming, every statement can update state or can depend on the state. That means that we can't cut the part of the program, like from statement 3 to statement 5, and execute them, because they depends on what was done in statement 1 and statement 2, and what the current state of place. Someone joined, please mute your mic. That means that to execute few separate statements from 3 to 5, we need to set up all places to some state. Probably I can mute him. Okay, I did it. I did it myself. This means that to execute few separate statements from the program, you need to mock or to set up all the values in all those places, because each statement can depend on each place that your program interacts with. In real world, people try to avoid it, but it's still the case, because if the language allows to do it, people will do it. It's, some basic rule of people. On the other hand, when you have a functional programming and you have few expressions, you can cut them. Just cut few expressions and run them. To run them, you need only arguments that are required by those expressions. And you don't need to care about what is in place 2 and place 1, because they accept few values and return one value. That's all. That means that you can run them separately, and you won't get any race conditions or such kind of crap. You can test them separately by just passing them necessary values for the execution. And there's a lot of benefits in it, but there's some problems in it. First very important problem, that you can't affect any of places using those expressions, because they just returns values to your root expression and doesn't change anything in any place. That means that your program, functional program, can't do anything useful at all. Like, it can't write a file to a disk, or to make a network request, or to update your database. Functional programming is very restricted in such sense. And let's talk about pros of functional programming. it's very safe. You can execute parts of your code, you can execute it in parallel, and you get a concurrency of your programs without any problems like race conditions or other stuff. Without re-implementing or updating your code, you just run those parts of the code in parallel and they works because they don't change any state. Those parts of program is very reusable. Those parts doesn't depend on any state. They just accept values and returns values. And if you can make those values for them, they will be very good with it and they will run smoothly. It's easy to decouple and test such programs. You just cut a part of your program and execute it in a very isolated environment which not relates to any other parts of the program. It's very easy to make a cache or laziness for such kind of programs because if they accept one value, they return very determined value. And if you passed the one value 3 times, all 3 times you will get the same value as a result. That means that sometimes you can memorize those value and don't do any computation and just return the result when you see that this parameter already been passed to this function. You just go straight to the cache and return the result without thinking if your program updating something in some place or somewhere else. The cache will work as you expect. And when you write a functional program, actually you describe what to do and not how to do. And it's very useful because you're describing actually business logic, which helps you to make decisions. And it's what we are programming for, to make our decisions easier. But there's some problems with functional programming. It's sometimes mind-blowing and it's hard to understand some concepts. But I hope it's not the case for people who are here today. And sometimes it may be not so efficient because if you implement exact lambda calculus, you will be using a notion of number like following. You have a 0 or successor to any other number. For example, 3 will be a successor to 2, and 2 will be successor to 1, and 1 will be successor to 0. And it's not a very efficient way to implement numbers and to operate on them, but it's how it's described in lambda calculus. But in the current state of our world, we have a lot of memory, and we have a pretty interesting algorithms like persistent data structures, which reduce, I will say, which reduce enough the complexity of underlying implementation of functional approaches that it allows to programs to be executed as almost as fast as imperative programs. And with pure functional programming, you can't do anything practical because you can't update places. That is why we're going to next slide, which says there is no versus, because you have to use both functions and procedures. Because procedures helps you to interact with world, help you to store some values, and to do some side effects. And functions helps you to implement business logic in decoupled and safe way. I think that's all about what I wanted to tell you for today. And we can start from questions and continue this discussion how to do something or how to use it in the real world or something like that. Thank you. Questions?
Andrew, thank you. Thank you very much. Nice to see this interesting seminar. Можно же перейти на все равно и
Yeah,
тебе.
you can ask questions in Russian.
Да, потому что не настолько скилловый, чтобы такие сложные вопросы задавать.
Uh-huh.
Насколько сложно находить людей и воспитывать их, в новых специалистов, которые понимают и принимают функциональное программирование?
Okay, it's a good question. I see another question in the chat, but I will answer this question first, and after that I will go to the question in the chat. The question is following: how hard to find a people who can work in the environment where people using a lot of functional programming? Actually, from my experience, it's very much the same as hire just a good person who wants to learn something. If a person interested in getting better in programming, it's pretty easy to make him aware of what functional programming is and how to implement it. Especially if you already have a pretty strong engineering culture and pretty strong engineers who already implemented some basic structure of your project. In most cases, it's much easier to involve people in development of this project because you can relatively easy decouple parts of the project and give to a newcomer this part of the project to explore. And doing some pair programming and code review, you pretty fast will explain basic concepts of functional programming. Probably I spent how much time? Half an hour for explaining all those details, and it's a basis that not enough yet, but very solid, and few more days with a newcomer will get him aware of approaches. He need to change his mind a little, but I don't have and don't see any problems for introducing new people to functional programming if you already have experience with it.
Спасибо.
And the second question about practical value of category theory. Actually, category theory and other theories that called functional programming in some groups of people doesn't have a lot of value for me because from some research that I've saw about how types helps to make your programs more reliable and stable. Those research shows that there is no correlation between types in the programming language and the quality of the code. That is why types are good. Those theories are interesting, but I won't use them in nearest future, at least, because there is not a lot value for me. But because I don't have a lot of experience with those theories, I can say that for sure they won't be useful for me in any future. But for nearest future, I don't expect that I or my team will be using them. And that is all that I can say for now about it. And the second question about learning, probably learning is a separate process because when you're learning, you're getting a lot of benefits despite the fact if you will be using them in the future or not. That is why learning may be worth it, but using maybe not so useful, at least now. Maybe in the future the category theory will be the dominance in programming and everyone will be learning it, but not now at least. And Ivan asking about static types versus dynamic types. Anyone have thoughts on it? No, nobody wants to tell us something about static and dynamic types. Okay, I will make some thoughts on it. Talking about static versus dynamic types, we need to understand that it's only about when we get feedback about that something wrong in our program. For example, using static types, we can analyze program on compilation phase. But actually, it doesn't. It's not very important when we get an error or warning about that something wrong with our code on compilation phase or on test phase, because the both phases are done before delivering the product to users, and that means the both types of typing, static and dynamic, can be used to find problems in your code before you delivering those products to users. That means, for example, in Clojure, you can use Clojure spec to make some kind of type system in your language and to make a lot of checks before you delivering the code. And for me, it's not very important if it's done during compile time or during test time. That's what I have to say about types.
Я позволю себе еще кое-что добавить. По моим наблюдениям, да, все-таки есть разная динамика. Например, динамические типы в JavaScript и динамические типы в Lisp, они очень сильно отличаются. То есть в JavaScript от типа зависит поведение своих переменных. А в Lisp, насколько я вкуриваю, там все, по сути, является строками, поэтому поведение всех типов, оно одинаковое. И не бывает такого, что у тебя переменная... Ну, там же нет переменных, да, по сути. Но аргументы поменяли у тебя тип. И, например, сложение у тебя двух чисел превратилось в сложение комбинацию двух строк. Вот, поэтому в Lisp динамика такая, которая поддается пониманию. В JavaScript намного больше... Ну, то есть не та динамика, с которой хочется работать.
Okay, the good idea that JavaScript dynamic types is a little different from Lisp dynamic types, and it's the question about values. At the beginning of the talk, I said that values is actually semantically transparent. That means that nothing coupled with those values. You treat them in different languages the same. You have a number 2 in JavaScript and you have a number 2 in Clojure, and those both numbers the same in both languages. But the implementation of languages can couple something with values, and it makes, I mean with variables, and it makes those values not semantically transparent. And what I can take from this note about JavaScript problems with adding two numbers and getting concatenation of actual strings, that JavaScript doesn't implement this property of value, that it's semantically transparent. And maybe it's not so good for functional programming in JavaScript, but a lot of people using JavaScript, and it's pretty successful language, and we will be using it for much more longer time. Few more questions and notes from chat. John London he mentions that he can see benefits of category theory in the languages that designed with category theory in mind. Yes, maybe, but anything that you introduce in language have pros and cons. And pros, for example, in Haskell, you make your code during compile time checked, and you get rid a lot of errors during this compile time, but you adding much more boilerplate for doing it. For example, in other languages, which not so strict, for example, the JavaScript or ClojureScript or Scala, there are much less restrictions on the way you write the code, and that make you implement some things a little easier and with less boilerplate. But when you get such power, you get a problem that you can screw up, and you can write a bad code which will be broken in nearest future. And maybe for building larger system, it's better to write in more strict language, but it's hard question because it's necessary to make a good research on it, and those researches are not easy. And I can't say that for sure Haskell will be beneficial for writing such big systems because it's not clear if it adds enough value and subtracts not so much usability from the language. My thoughts about functional reactive programming. Can you make a more precise question? Actually, I don't have a lot of thoughts in my basic life about FRP, but if you have more precise question about it, I can try to answer it. I have a question for you. Do anyone have some experience with functional programming in production using during their day job or using in their organization? Alexander says that they started to rewrite their architecture, separating two parts of the code. First part, which is probably a business logic, which doing some immutable operations like in functional programming, and the other part is muting one, which actually access network or files and so on. And they're doing it in C++ using a pipeline design pattern. Actually, I don't remember the name of all design patterns in the world, and I'm not sure what this pattern mean in C++ because I don't write a C++ for almost 7 years, I think. But we can make a call. Actually, we already decided that we will make a call with Alexander about text editors and development environments to discuss them. And we can discuss your precise case if you give a more information about it. I don't have a lot of experience with FRP, and especially I don't have a production experience with it. That is why for now I can't get you a lot of interesting insights about it. But later probably I will make some architecture based on those approach, and we'll see how it works. And after that I will be able to discuss it more in more details and giving you more ideas about how to use it and what benefits and trade-offs of it. About my last question, does anyone use functional programming in their job? If not, just make a minus in the chat to make me know that you're still here and not sleeping yet. We have 7 more minutes for discussion, and I would like to see people telling about their experience with functional programming. Ivan is actually a very interesting and smart guy who has a lot of theoretical knowledge and knows about a lot of interesting trends in functional programming, but he don't use the functional programming in his real world. Jen says that they're using FP on several of their projects. Can you describe a little more about your projects, the size of them, and kind of field where are you using those projects? People from company Urbest using Clojure and ClojureScript for their developments. It's cool. It's very interesting that people getting to know some functional programming languages and also using them for real-world application. Jen says that they uses functional programming for mostly front-end, for booking flows, progressive web apps, and other stuff. Nice to know. And what technologies do you use? From what you're asking about Haskell, it's probably Elm or something similar. Alexander says that they use lambdas, recursion, and streams in their day life. Actually, it's pretty good, and it's interesting to see that much more people and much more languages adopt a lot of functional ideas to make their code simple. Simple to test, simple to execute in parallel, and simple to develop. I think that this trend appeared for a good reason, and now we have enough resource, enough memory, enough processing power to run languages with functional paradigm and to write code which more about the logic, not about implementation.
Андрей, а меня сейчас только ты слышишь?
No, everyone can hear you. But you can ask your questions or tell your story about using functional programming.
Yes, I think it's a story, not a question. I'm using Emacs, and once I get a bug in some mod and I start debugging, and I want to know how can I fix it. And I found one interesting thing with functional programming. I found that I can take a part of code, copy it, and paste in evaluation part, like it's naming REPL. Yeah, I can paste it. I can put needed argument in it and evaluate.
Oh.
It's this small part in which bug is. After that, I went to my project in Walk, my production project with Java, and I have to fix bug in code in this project, and I understood all of complexity with debugging in object-oriented and imperative programming code, because a bug was in method with modification, and I couldn't take this part because it was он был завязан на множество других вещей. Да, у меня не хватает экспириенса в английском, к сожалению. It was too complex to take and evaluate it in isolation, because imperative programming doesn't prefer it. Yeah.
Okay. It's very cool story, and it's related to the part of the talk where we discussed imperative and functional approach, and this a really cool story because it describes actually the same idea that was mentioned earlier, that you can cut the part of your functional code, take it in a separate, isolated environment, and work with it separately without knowing anything about the rest part of the world. And you can debug it, or write tests, or execute, or do whatever you want with this part, and it will be very easy. But doing the same in imperative programming much harder. And actually it's possible. It's a lot of approaches to make your code much more decoupled in imperative programming, but it's much more easier to not follow this approach, or to understand too late that you get inside this mess, and you have to rework a big part of your project to make it decoupled. Thank you for all stories, discussions, and questions. I hope it was very useful, and I think that it's much more interesting questions and ideas that people want to discuss. And I think that we can make another stream or another talk and discuss much more interesting ideas to see real-world examples and application of functional and imperative programming, or different functional languages and approaches. But let's do it later, because we already spent a lot of time, and I will answer all your questions in the chat in Telegram that you already wrote in comments. and you're free to ask me questions directly. I will accumulate a list of ideas that we can discuss next time, and we'll see you next time. Thanks a lot for everyone.
Andrew, thank you very much. Nice seminar.
You're welcome. Okay, see you. Bye bye, guys.